Hi there, it's Mr. Mitchell here from Malmesbury Science. Today I'm going to be doing an A-level chemistry practical on water of crystallisation. Water of crystallisation is the fixed amount of water in some salts required to form the crystals from their aqueous solution. Now, copper sulfate has a blue crystal when it's hydrated, when it contains this water of crystallisation. However, when heated and the water is removed, turns white. The salt we're going to be using today is magnesium sulfate, a naturally occurring salt found in Epsom salts. By measuring the mass before and after heating the hydrated salt, we can find out how much water has been lost, and thus how many moles of water are attached to each 1 mole of magnesium sulfate. The first thing I'm going to do is measure the mass of a crucible and a lid. It's important in this practical to weigh exact masses of things, so we do a lot of our work by calculation. The mass of my crucible and lid is 35.63 grams. The next thing I'm going to do is add approximately 2 grams of magnesium sulfate. My balance now reads 37.66 grams. So the mass of hydrated magnesium sulfate I have is 2.03 grams. I'm then going to put my crucible onto a pipe clay triangle and heat it until I remove or evaporate off all of the water. I'm going to light the Bunsen burner with a half open air hole. So as I said, we want the air hole about half open. We don't want to heat too strongly, as there's a risk that we may crack the crucible. The main risk involved in this practical is spitting of the solid when you lift the lid. With that in mind, you really should be wearing goggles for this practical. That's also why we heat it as gently as possible. We're going to heat it gently for about 5 minutes. Now in doing that, we're trying to remove the water. To make sure that the water is all removed and we don't have any steam trapped in the crucible, we need to gently lift the lid every so often. When we lift the lid, you carefully use metal tongs and lift just one side gently to make sure any water vapour is not trapped inside the crucible. This water vapour could, when cooling, recrystallise within the structure of the magnesium sulfate, not giving us an accurate result for our experiment. Once I've heated for about 5 minutes, I'm going to leave my crucible to cool. I need to leave the lid on again so that water vapour from the atmosphere is not recrystallised within the structure of the magnesium sulfate. I'm going to reweigh my crucible and lid with the now anhydrous magnesium sulfate. Anhydrous means there's no water of crystallisation. I've driven off all of the water. My crucible now weighs 36.63 grams. To calculate the mass of water lost, I've taken away the mass of the crucible, lid and anhydrous magnesium sulfate from the mass of the crucible, lid and hydrated magnesium sulfate. So to find out the mass of water lost in my experiment. So that is 37.66 grams, take away 36.63 grams, which gives me a mass of water of 1.03 grams. To calculate the mass of anhydrous magnesium sulfate, so the magnesium sulfate without the water of crystallisation, I take away the mass of water from the original mass of the hydrated magnesium sulfate. So that's 1.00 grams of magnesium sulfates. We now need to calculate the number of moles of water that are bonded to every 1 mole of magnesium sulfate. To do so, we're going to use the equation moles equals mass divided by formula mass, or you might know this as moles equals grams over amps. The number of moles of water in my experiment that I've lost, I'm going to calculate using the mass of water, which was 1.03, divided by the formula mass, which is 18. That gives me a number of moles of 0.057. The number of moles of magnesium sulfate can be calculated in the same way. Using the mass and the formula mass, the number of moles of magnesium sulfate is 0.0083. We now need to work out the stoichiometric ratio of moles of water to moles of magnesium sulfate. To do this, we're going to divide the number of moles of water we calculated, 0.057, by the moles of magnesium sulfate, 0.0083. The ratio of magnesium sulfate to water, for every 1 mole of magnesium sulfate, you have 7.125 moles of water. The actual ratio of water to magnesium sulfate is 7:1. So from rounding, we can see that actually our experiment has been pretty accurate in getting this result.